Hey everyone, we're going to go ahead and get started here. I'm Major Jeremy Dehart. I'm the Assistant Director of Operations at the 14th Weather Squadron. Thanks for joining us for our Summer Quarter 2015 Climate Services webinar. We do ask that if you have any comments or questions that you please hold them at the end. You can ask your questions over the phone or type them into the DCS window, and we'll have someone monitoring the DCS messenger to questions. Also, we ask that you don't on mute unless you have a question until. Finally, your feedback on the utility of this webinar is important to us. So obviously, it's a new setup for us with DCS. We'll have a little instruction at the very end on how to provide us feedback using the form that's been loaded in. And get started. First thing we want to do is look at some updates to our website. And of course, we've got a pretty extensive product line that we hang out there on the website, and we're always looking at ways to make those products more discoverable for our users. So we've developed this little guide. You can see here it's a product help PDF. So it's in PDF form. You can see two different places you can access it. It's the same form either way. There's the menu bar across the top of the web page, and then we've added a quick link button down towards the bottom of the page as well. Click the link, and here's what opens up. It's basically a frequently asked question type of format. So it's designed if you really aren't sure exactly what product you're looking for, so you can kind of peruse through these and ask yourself, generally speaking, what kind of product would you be? Hourly temperatures, or maybe a plot of wind speed and direction. Frequently, our most requested product is essentially a tailored climate summary, or OCS2. So we're going to take a look at that as an example. Click that OCS2 link, and it pulls up a set of instructions. For one in particular, you can put in your station identifier either by platform ID or by station name, and it just takes you through each step. Gives you a list of formats that you potentially could open that in, and then here is the end product. It brings up basically a tabular set of climatological data for that station. Also, it walks you through the advanced options button. You can click on that and look at some other parameters here. Say maybe you want to look at your times in Zulu instead of local time, or you want parameters with the precipitation. You look at extremes or some of the thresholds that you can set as well. You can set those and tailor those to how you want to view that data, and then just put that in, and it'll load that product for you. So back to the menu, maybe that's not exactly what you were looking for. Maybe you want something a little more graphical in nature. Well, our climogram is essentially an OCDS in graphical form. So again, you just kind of read the question list, prompts you to where you might want to go. So you click on the climogram link, and it walks you through a set of instructions on how to open up the climogram product. You can walk through those, click open, and there it is. There's a graphical representation of basically our OCDS, and you can see monthly as well. So these are just a few examples of some of these products. Again, it's designed for if you're really not sure what you're looking for, you can kind of peruse this product and click through, and there's an example for essentially all of our products that we have here. And of course, as always, if you still can't find exactly what you're looking for, we direct you to our support assist request page, where you can always submit a SAR and get the product that you need. Second thing we wanted to update you on, the state of the climate slides that we're getting ready to present here. We've updated our CMAP webpage to include right under where we have the sit rep that's posted every month. We're also going to be posting monthly these following state of the climate slides. You can come back and reference those at any point in time. So again, these are the main updates we've made since the last webinar. We hope these are helpful to you in helping you product that you need, provide a little more utility for navigating our website. So with that, we're going to go ahead and turn it over to Tech Sergeant Beasley for the state of the climate.
The state of the climate. Joined us in April, we showed a few charts displaying Madden Julian Oscillation, or MJO, and the El Niño Southern Oscillation, or recent global temperature. Today, we will look at those oscillations again and see and effects on the climate. Remember that a teleconnection refers to recurring and persistent large-scale patterns of pressure. First, we will review the current and forecasted phase of the MJO. Remember, the MJO is an intraseasonal fluctuation of primarily the tropical Indian and Pacific Ocean, responsible for the majority of short-term weather variability in the atmospheric and oceanic. Displayed on the left is the real-time multivariate MJO or the RMM diagram, which is used to track and forecast the 8 phases of the MJO. The phase diagram on the left shows the evolution of the MJO over the last 40 days of observation, along with the 15-day ensemble GFS. Dark shading indicates 90% of the model ensemble members fall in this area. The first part of June, the MJO had a low amplitude wave. Amplitude then quickly began rising through to July 5th as the MJO positively interacted with El Niño in the tropical Pacific. The MJO over the past month has remained very active with its very high amplitude. Amplitude on July 5th was the highest July value on record dating back to 1981. The diagram on the right is a depiction of forecasted anomalous outgoing long-wave radiation, or OLR, based on the ensemble GFS forecasted RMM phase over the next 15 days. Blue shades show negative OLR anomalies, which are indicative of enhanced convection. In these areas, you can expect increased convection as compared to the seasonal norm. The yellow and red shades represent positive OLR anomalies indicative of suppressed convection. In these areas, you can expect a decrease in convection. 14th Weather Squadron also uses this information to compile our Pacific tropical that is shown here, which is used by RPA pilots in support of Global Hawk mission planning. This forecast product is updated weekly and can be found on the CMAP webpage. Using information about the MJO, its projected phase, and other model predictions, we are able to get an idea of what to expect for our forecast. We also evaluate the El Niño conditions to determine its effect on our forecast period. The MJO is forecasted to remain relatively inactive for the forecast period depicted here, so this forecast was based on persistence and El Niño influence. Tropical Pacific Convective Outlook is produced once a week in collaboration with the Climate Prediction Center. We are currently in an El Niño state of the ENSO. There has been a continued increase in sea surface temperature, enhanced equatorial convection, and increased persistent low-level westerlies. All of these are characteristics of El Niño conditions and are expected to persist over the course of the next few months. This year's El Niño is expected to be one of the strongest in the last 50 years. There is a greater than 90% chance that the El Niño conditions will continue into the Northern Hemisphere autumn, and an 80% chance it will last through the 2015-2016 winter, according to the Climate Prediction Center. Looking at the International Research Institute, or IRI, and CPC plume of the model ENSO predictions, we can see that the majority of the models are predicting that the sea surface temperatures in the Pacific will continue to be at least 0.5 degrees Celsius higher than normal into the beginning of the 2016 year. El Niño conditions typically bring a suppressed Atlantic hurricane season, cooler and wetter conditions in the southeast U.S., warmer conditions in western Canada and Alaska, and wetter conditions in California. Now we will examine how these oscillations impacted global temperature trends over the past month, 31 May to 30 June. There has not been much change in temperature anomalies of the past few months. Eurasia continues to experience above normal temperatures. As noted in our sitrep, Pakistan experienced a deadly heat wave that claimed 800 lives. On June 20th, Karachi International reported record temperatures of 44 degrees Celsius. As typical during El Niño, both the western United States and western South America experienced warmer than average conditions. Looking at the precipitation trends from the past month, 31 May to 30 June, you will see connections with the phases of the MJO and ENSO in the precipitation anomalies. As previously mentioned in the last webinar, the MJO brought above average precipitation to the Horn of Africa and India. As noted in our sitrep, to the east of India and Bangladesh, above average precipitation brought torrential rainfall, which led to localized flooding and embankment failures. The MJO brought drier than average conditions in western U.S. The ENSO brought wetter than average conditions to Mexico, the equatorial Pacific, and western South America, as well as continued drier than average conditions in parts of southern Central America and northern South America. As noted in our sitrep, the water supply for over 20 million people in the city of Sao Paulo is at 15.4% useful volume and 19.9% useful volume reserve. Now that we have reviewed current global conditions, let's look to see what is in store for the future. In August, look for continued warmer than average conditions over much of the globe. Expect persistent warmth in Eurasia and above average temperatures off the west coast of South America into the Pacific. Also expect persistent warmth in the Northeast Pacific. Precipitation rates will be above average due to El Niño along the equator in the Pacific. Drier than normal conditions are expected in Central America into northern South America, Indonesia, and India into the Arabian Sea. Drought has improved slightly across the globe from the last webinar. Intense drought has continued in the western U.S., western and northern Canada, and Central America. Pockets of intense drought continue in South America and in Africa. Drought in southwestern Russia and Iran has expanded, while drought has continued to intensify in the Korean Peninsula. Drought also continues in Bangladesh and Australia. Now that we have reviewed the current global conditions, let's look at what is in store for the drought conditions into September of 2015 are similar to the current conditions. Expect a slight improvement in the western U.S., western and northern Canada. Central America, drought conditions will intensify slightly. Also expect drought intensification in northern South America, equatorial Africa, as well as the western Sahel. Southwest Russia, look for drought conditions to spread slightly. Drought conditions will improve in eastern India into Bangladesh due to the monsoon rains. On the Korean Peninsula, drought is expected to intensify. Due to a strong El Niño, Pacific typhoon season is expected very active, and the Atlantic season be suppressed. As of now, Pacific tropical storms, typhoons, and super typhoons are more numerous than during this time in 2014. The amount of typhoons through July of 2015 has tripled compared to the time last year, while the amount of super typhoons from the July 2014. As of halfway through the typhoon season, the number of super typhoons is 80% of normal for an entire season, and the peak of the not yet occurred. The peak of typhoon season typically occurs in August and September. Expect an increased amount of activity in the Pacific as the year goes on and El Nino gets stronger. As you can see on the chart, Atlantic hurricane season has been somewhat suppressed this year compared to the historical averages. While there have been 3 named storms, there have been 0 major hurricanes this year. We will continue to monitor those areas to see how El Nino is influencing cyclone development. Now, Staff Sergeant Brantner will highlight some of our recent tailored support.
Hello, I'm Staff Sergeant Brantner, and today I'll highlight some recent SARs. Before I start, I do want to mention that we have updated our recent SARs page. On the front page of our site, simply click on the recent SARs icon to see common tailored support requests, as well as recent SARs which will be updated on a quarterly basis. Now let's move on to some recent SARs. On April 25, 2015, Nepal experienced a 7.8 magnitude earthquake which killed more than 9,000 people and injured over 23,000. Hundreds of thousands of people were also left homeless as entire villages were flattened along with centuries-old buildings. Besides the earthquake, there were numerous aftershocks and avalanches with the risk of landslides. These aftershocks were still being felt into the middle of May. With relief operations expected to take some time, we were asked about the upcoming monsoon season. Leveraging monsoon start and end dates from the Government of Nepal Ministry of Science, Technology, and Environment, the SAR team developed an analysis of historical Nepal monsoon onset and end dates by merging their data with El Nino and La Nina periods. First, we found that the monsoon onset was anywhere from 1 week early to 2 weeks later than average during El Nino years. Furthermore, our analysts determined that the average monsoon onset was around June 10th through 12th, while the average monsoon onset during El Nino was June 15th. This chart depicts cumulative precipitation and shows the effects of El Nino and La Nina on precipitation total. While the median monthly monsoon precipitation is approximately 10 to 15 inches and totals on average between 50 to 60 inches annually, the delayed onset typical of El Nino years leads to a decrease in cumulative precipitation. Regardless of any potentially abnormal monsoon conditions, locally heavy monsoon rains still increase the risk of localized flooding and landslides following the recent earthquake. By leveraging our own ENSO data along with the precipitation data, our analysts were able to provide a better estimate of monsoon precipitation. Lastly, a forecaster at the 18th Weather Squadron headquarters in Fort Bragg was looking for climatological data to use in providing staff weather briefings and mission planning to support. Rather than simply providing the data, we coordinated all of the mission limiting criteria and automated the production of a stoplight chart for use in briefing, similar to a product already in use at the 18th. By automating the process, we can now create this product for any location in just a few minutes, as long as the station has a sufficient amount of data. These are just a few examples of what our climate analysis team can do to provide you with what data you need. An important thing to keep in mind is that we generally can help you better if we have as much information as possible and we know what you're trying to do. If you need to submit a SAR, go to https://www.climate.af.mil and hover over the Request Support tab. Then click on the Submit Support Request. We look forward to hearing from you. This concludes this quarter's webinar. Please take a moment to provide us your feedback on this webinar as we look forward to incorporating your inputs into future webinars. The form can be downloaded by clicking the arrow found in the lower left-hand corner of DCS. At this time, we'd like to open up the floor for any questions or comments.